Citations are not enough if half the answer is unsupported. Evidence coverage checks whether each claim actually has backing. You'll understand the pattern behind a pipeline that slices an answer into checkable claims and scores their evidence coverage. I'm Professor Pi, teaching AI engineering and LLM systems with simple Python. Start with the problem. When a retrieval-augmented generation system answers a question, it mixes facts, inferences, and confident phrasing. Humans trust answers that are traceable to source passages. The pain point is obvious. Long answers can hide unsupported claims, and simple citation counts do not tell you which sentence is backed. Evidence coverage scoring gives you a way to split an answer into atomic claims, look for matching evidence, and produce a per-claim score so you can flag risky output before it reaches users. Conceptually, this is straightforward. We turn an answer into short candidate claims, normalize wording so paraphrase can still match, measure token overlap with retrieved passages, then threshold those overlaps to mark supported versus unsupported claims. The result is transparent and auditable. The gap is that pure lexical overlap can miss paraphrase. Project Preview. We'll build a compact pipeline that extracts claims, focuses them on the user question, measures lemma overlap with retrieved evidence, thresholds the results, and outputs a report you can act on. That keeps the idea practical and easy to extend. Quick note, this code is designed to teach the core idea clearly. Library versions and local setups can vary, so check the official docs if your setup behaves differently. To begin, we need to pull out candidate claims from an answer, so later checks have something small to match. This snippet turns an answer into a short list of verb-rich candidate claims you can check automatically. It loads spaCy, runs answer text through NLP to produce doc, then uses doc.sense with a simple verb filter to collect assertions favoring sentences with a main verb because those usually carry the assertion. The code prints a diagnostic like candidate claims equals 2, so you can confirm it produced 2 compact claim strings. Input is the raw answer text, and output is a list of claim strings you'll pass to the next step. We only want claims relevant to the user's intent, so next we normalize and focus them. This example narrows claims to those that actually relate to the question by lemmatizing both sides and filtering. It parses question text with NLP to build question terms as a lemma set, then processes each claim sentence into claim terms using the same lemmatization. The code zips original sentences with their lemma baskets into focused pairs and drops claims that share little with the question, cutting noise and concentrating checks. A print like focused claims equals 2 confirms both statements survived and will be scored. Now, we need a way to measure how much a piece of evidence actually covers a focused claim. This code quantifies how much each focused claim is lexically covered by evidence snippets. For every text in evidence texts, it computes evidence terms as a lemma set via NLP, then builds claim support by measuring the intersection size with EV divided by len terms for each evidence candidate. The result is a list of overlap ratios per claim, and the code takes the maximum overlap per claim to represent the best match, producing an auditable metric. The snippet reports best overlap equals 0.62 to show which revenue-related sentence currently has the tightest lexical coverage. Raw overlap numbers are informative, but we need a decision for automation. This snippet turns those overlap scores into pass-fail flags using support threshold, so we can mark which claims earned enough coverage. It computes coverage flags as booleans for each score, and then summarizes them with supported ratio. Tweak support threshold to change behavior. Higher values demand near-exact matches and lower false positives. Lower values accept looser paraphrase and increase recall. The output supported ratio equals 0.50, warns that only half the claims met the current bar and should be reviewed. Finally, package the results so orchestration code can act on them. This example wraps the spaCy overlap data into a reusable report and pulls out unsupported claims for auditors. It builds report as a list of entries, bundling each focused claim with its best score and supported flag. Computes unsupported as the exact text that failed the threshold, and also returns total supported plus a single coverage score, so a deployment hook can decide to publish or hold an answer without losing claim level detail. A printed coverage score equals 0.50 signals the answer still needs stronger evidence before it is safe to ship, while the report gives human reviewers a direct starting point. In a real system, you would map claim text to document IDs and include retrieval timestamps. And you might use embeddings to capture paraphrase where lexical overlap fails. For production, add a small audit trail attaching the evidence snippet IDs to each report row so reviewers can click directly to sources. To recap, we built a pipeline that pulls short claims from an answer, normalizes them, measures lemma overlap against retrieved passages, and reports per claim support. Use this when you need transparent, auditable checks on RAG answers before you release them. One caveat: lexical overlap misses deep paraphrase and semantic matches, so combine it with semantic retrieval for best coverage. Wrap, punch. Next step: scale this by replacing exact lemma overlap with an ANN-backed evidence index, and measure coverage and latency across a larger corpus to find the right support threshold for deployment. If practical AI engineering helps, subscribe and watch the AI engineering videos.